Welcome to Lesson 4 of Module 3, Operations with Rational Expressions. Don't mind the little background change. I'm actually in the PP Islands right now. I told you in the beginning of the course that I live and teach in Thailand, and we're just on a little vacation, so I came over to the PP Islands, but we still have math to do, so let's get started. So some key terms in this lesson are rational expression and domain. So a rational expression is a fraction where the numerator and or denominator are polynomials. And the domain is the set of all possible x values that do not make the denominator 0. Because if the denominator is 0, what does that mean? That means that the expression is undefined, right? We can't divide anything by 0. That would make it undefined. So some key steps would be to identify restrictions and then simplify. So you can identify your restrictions by setting your denominator equal to 0 and solving for x. That way you know these are the x values that x cannot be, because that would make the expression undefined. And then you can simplify the expression by factoring and canceling out common terms. So let's take a look at this one here and practice simplifying. We have x squared minus 9 over x plus 3. So the numerator we could factor. If you remember from the lesson on factoring, this is a difference of squares. So we can factor x squared minus 9 and rewrite the expression as x plus 3, x minus 3 over x plus 3. So now we can cancel out x plus 3 and x plus 3. And we've simplified our expression to just x minus 3. Finding the domain and identifying restrictions. So we have this expression here, 2x plus 1 over x squared minus 9. Remember, I said to identify the restrictions, we're going to take that denominator and set it equal to 0 to solve for x. So we just factored this expression in the previous example, right? It's the difference of squares. So x squared minus 9 becomes x plus 3 times x minus 3. When we set each factor to 0 and solve for x, we get x equals positive 3 and x equals negative 3. So what this means is that the domain is all real numbers except for positive 3 and negative 3, right? It's literally any number except positive 3 and negative 3, because those are the two values for x that will make the denominator 0 and make this expression undefined. Please pause this video and work on the Lesson 4 Level 1 problems in the workbook. In Level 2, we're going to perform some operations with rational expressions, and we're going to start by adding and subtracting. So we have this expression here, 2 over x plus 3 over x plus 2. So just like if we were adding regular fractions, unfortunately here, we can't use the calculator just as easily as we do with just regular fractions, but we have to find a common denominator. So the common denominator here is x times x plus 2. All you need to do is multiply the denominators together, and that's your common denominator. So then we'll rewrite each expression with the common denominator. So the new expression becomes 2 times x plus 2 over x times x plus 2 plus 3x over x times x plus 2. So all you do is you take the first term, you take the first fraction, and you multiply the numerator with the denominator of the second term. And then you take the second term and you multiply the numerator with the denominator of the first term. So now add or subtract the numerators. In this case, we're adding. So what I did here was I applied the distributive property for the first term, 2x plus 4, and then added the 3x all over the common denominator, which is x times x plus 2. And then combine like terms, right? 2x and 3x become 5x, and 4 remains the same. So we get 5x plus 4 over x times x plus 2. Then you simplify the resulting expression if possible. In this case, there is no way that we can simplify this any further. So this is our final answer. Next, we're going to multiply and divide rational expressions. For multiplication, in my opinion, this is the easiest one because all you have to do is multiply the numerators together and multiply the denominators together. After that, you'll factor and cancel the common terms. So multiplying the numerators and the denominators, we get x plus 3 times x minus 2 over x minus 2 times x plus 1. So now x minus 2 and x minus 2 are going to cancel out, and we're left with x plus 3 over x plus 1, right? Simple. Now on to division. We're going to flip the second fraction and multiply, right? Just like dividing regular fractions, you're just multiplying by the reciprocal. So let's rewrite this as x squared over x plus 3 times x minus 1 over x, right? This second term here is just the reciprocal of the denominator in the expression. And now we just have to multiply. We're going to multiply straight across and multiply our numerators together and our denominators together. So we get x squared times x minus 1 over x times x plus 3. Now we can simplify this even further because x squared divided by x is just x, right? So now our numerator becomes x times x minus 1, and we divided out that x in the denominator, so our denominator is now x plus 3. Please pause this video and work on the Lesson 4 Level 2 problems in the workbook. Moving on to Level 3, simplifying complex rational expressions. So this is going to be very multi-step. We have this complex rational expression here, 2 over x plus 3 over x plus 2, all over 1 over x minus 1 over x plus 1. It looks intimidating, I'm not going to lie, but we're going to break it down into multiple steps. The first step is simplify the numerator. Just deal with the numerator, ignore the denominator for now. So simplifying the numerator, right, we're adding two rational expressions. So just like we did in the previous level, right, we need to find the common denominator. The common denominator is x times x plus 2. So simplifying the numerator, we get 2 times x plus 2 plus 3x over x times x plus 2. We'll simplify this even further by using the distributive property. And we get 2x plus 4 plus 3x over x times x plus 2. We'll simplify it even further by combining like terms. And we get 5x plus 4 over x times x plus 2. If you notice, this is the same exact example from level 2 when we added and subtracted rational expressions. So that's step 1, simplify the numerator. Now we have to simplify the denominator. So here's where some strategy comes in. We want to simplify the denominator in a way where we're going to get the same common denominator as we did in the numerator, right? Which was x times x plus 2. So simplifying the denominator, we get x minus x plus 2 all over x times x plus 2. Simplifying this even further, we distribute the negative and we get x minus 2 over x times x plus 2. Combining like terms, we get negative 2 over x times x plus 2. So that's our simplified denominator. Next, remember, division becomes multiplication, right? We're going to take this, our denominator, and flip it and multiply the numerator by its reciprocal. So we get 5x plus 4 over x times x plus 2 times x plus 2 over negative 2. So x times x plus 2 and x times x plus 2, those are going to cancel out. And we're left with 5x plus 4 over negative 2. And we can just rewrite that by pulling the negative sign out to the front. That's the proper way to write negative fractions. The negative, whether your numerator is negative or your denominator is negative, it doesn't matter. It makes the entire fraction negative. So the proper way to write it is to put that negative sign on the outside of the fraction. So we get negative 5x plus 4 over 2. And that's our final answer. Please pause this video and work on the lesson 4 level 3 problems in the workbook. Once you're finished with the problems in the workbook, please stop this video and move on to the next one for lesson 5.